So we're going to look at 115 and 116. So you're being given your velocity function, which is 10t, which you graph that, you would get a diagonal line, slope of 10. You have your axes labeled, time in seconds, velocity in meters per second. You weren't necessarily given your units of meters per second, but in the context of a problem, we can put some units in here to help us make more sense of what's going on. If you wanted to find your slope of this and what that would mean, it would be change in y, while your output is meters per second, over change in your input, which is seconds. So when we work that out, instead of dividing by seconds, we multiply by the reciprocal, 1 over seconds, so we get meters over seconds squared, which is your units for acceleration. Or acceleration in this case, when you look at your slope of a straight line, which is 10, your acceleration would be 10 meters per second squared. So what would the units for your area represent here? Well, if you wanted to look at your area, for the most part, look at your units in the terms of like a rectangle, and you'd want to do this side, which is meters per second, times the other side, which is seconds. And so meters per second times seconds, the seconds drop, leaving you with meters. So the area here underneath this curve represents distance. If we wanted to go ahead and find the area of this, it is the shape of a triangle where we'd have to go 1/2 base times height. We go 1/2. Our base, we would go over here, say t seconds, because it says for the first t seconds. So we're going over to some spot here, t seconds. And that, well, then how far up it is? Well, it says right here, no matter what you plug in, you are then going to have an output of 10t. So we go over t seconds, we go up 10t for our height, and we multiply this. 5 times 10 is a half, t times t, we get this. So our area would be, in this case, 5 times your time squared, and the units would be, in this case, meters. So there are some problems where your slope has meaning and your area has meaning. Check your units, just like we did here, and it'll tell you what's going on. In 116, we can look at our units. We could do our area. Well, if we were looking at our area here, for the most part, we could do a rectangle. And by the way, when you graph this, that's a parabola, so you should be familiar with that. That's why the graph looks like it does, and I labeled my axes. If we were looking at area, it would be my vertical units of meters times my horizontal units for finding the area of that rectangle. And if we do that, we get meters times seconds, which is meter seconds, but meter seconds is meaningless in the context of real life. So in this case, our area doesn't mean anything. If we were looking at slope, we'd go units of your y over units of your x. We get meters per second, and we know the meters per second is units for velocity. So in the context of this graph, our area underneath our curve is meaningless, looking at our units. But looking at your units, your slope is meaningful in its velocity. So if we were looking for our velocity, we would have to do our slope, which is our IROC, and so we'd have to do our IROC formula, subtract your original function, go t plus h for your input here. You'd have to go t plus h times t plus h, FOIL that, distribute through your 20. You'll notice that your 20t squareds drop. Everything has an h in it, they drop. Now that you get h out of the bottom, you can plug in 0 for your h. Causes this to drop, you get 40 times t. And in this case, we are looking at slope. Our units would be meters per second. So if you come to a problem and you're not sure if you should look at slope or if you should look at area, look at your units. Your units will always tell you what to do.